Now that you're familiar solving traditional quadratic equations, either through factoring, completing the square, or the quadratic formula, we're next going to tackle equations that we term quadratic in form, which means the equations are not quadratic in the beginning, but through an appropriate substitution we can make the equation look like a quadratic equation. And the key to recognizing whether an equation is quadratic in form is to see if one of the variable expressions in the equation is the square of another variable expression in the equation. So the first example we're going to look at is x to the 6th minus 7x cubed minus 8 is equal to 0. Now if we were to let u be equal to x to the 3rd in this equation, then if I were to square u, that would be then squaring x to the 3rd power, which then is equal to x to the 6th. So you can see then that x to the 6th is the square of the variable expression x to the 3rd power. So now with these substitutions we can rewrite the equation as u squared minus 7u minus 8 is equal to 0. Now the equation in this form will be much easier to solve, and we can use any of the methods we've talked about for solving this quadratic equation. And I think you can see it will easily factor, and will factor into the quantity u minus 8 times the quantity then u plus 1. So if we set each factor to 0, we can see that u will either be equal to 8 or u will be equal to negative 1. Now we want to be sure not to stop at that point because we want to solve for x, which is the variable that was contained in the original equation. So now we'll go back and replace the u with what it was equal to in the very beginning, which was x to the 3rd power. So we will have then next x to the 3rd is equal to 8, or x to the 3rd is equal to negative 1. And so to end up then isolating x, we'll have x is equal to the cube root of 8, which is equal to 2, or x will be equal to then the cube root of negative 1, which we know then to be negative 1. So then our solutions to the equation will be x being equal to 2, or x being equal to negative 1. Now let's next revisit the equation we just solved using a u substitution. You might have noticed perhaps that this equation is actually fairly easy to factor. Now since it's a trinomial, what we can do is set up our two parentheses and determine what must go in each position for each of the binomials. And because we've x to the 6th there as the first term, it should seem reasonable that we need an x to the 3rd and x to the 3rd as the first terms in each binomial. And that's dictated by the fact that the variable portion of the middle term is x to the 3rd. So now we need to determine the factors of negative 8 that will add up to be negative 7. I think you'll agree that would be minus 8 here, then plus 1. And now if we set each factor to 0, we'll have x to the 3rd is equal to 8, or x to the 3rd is equal to negative 1. And as we did before, we'll take the cube root of both sides, so x is equal to the cube root of 8, or x will be equal to 2. And in the second equation, x will be equal to the cube root of negative 1, or x then will be equal to negative 1. So keep in mind, if the equation is fairly straightforward and can be factored fairly easily, that might be a better way to go than using a u substitution. Now, in the next example we'll consider together, the u substitution I think will be crucial in order to solve the equation.